Hi there. Welcome to my workshop. Today I'm going to cover building an outfeed table. This outfeed table that I built recently was specifically for my table saw, of course, which is a Ridgid R4512 table saw. Pretty decent saw, not your Cadillac, not your low-end one. Good general purpose saw. So anyway, I'm going to cover the details of this. I'm not going to give you all the specifics and the dimensions of everything. I'll give you some ideas and some basic dimensions. So some of the key parts of this you're going to find your top itself, and then probably the more difficult part of the saw or of the outfeed table is just building the mechanism to support the saw when it's out. I had looked at a few different designs. I actually stole this design mainly off of another YouTube video. There's several of them out there. It's basically a dovetail design. Works pretty slick. I made a few enhancements to it to make it a little bit better. At least in my mind, they made it a little better. So when I looked at this, one of the things that based on my shop, because I got a pretty small shop, I needed something that was going to keep out of the way when I'm not using it. So it definitely had to fold in. I didn't want legs hanging out here that I would trip on or kick or do that sort of thing. So this works pretty good. You can basically slip it up, drop it down, it's out of the way when you're not using it. When you need it, you pop it back up. Pretty easy to do, everything's kind of set. And I'll kind of go through the details of this kind of sliding dovetail a little bit with you. I'm not going to go through and give you exact dimensions on things, but I'll give you some approximates, and you can kind of figure it out yourself. There's lots of ways to build this. I'm sure there's better ways to build this than what I did. So go ahead and steal what you want or throw away what you don't like. So we'll go from there. Okay, so let's just start at the top. No pun intended. So building the top is basically made up of a few different types of woods and different sizes of woods, of course. So part of my goal in building this is to use a bunch of the wood I had in the shop. I didn't want to go out and buy more wood. I got tons and tons of different sizes and pieces and styles of woods and types of wood. So I just basically used whatever I had laying around in the shop. So there's 3 different species of wood in here. We got basically just oak plywood, 3/4 inch oak plywood that I had. I had some poplar from a different project I was working on left, so I used that for the kind of framing in the oak. And then the base of it is just some pine, some 2x4 pine that I used. Actually 2x4, and then there's a 2x6 that's on the main edge of here that mounts up to the table itself. So fortunately, I do have a planer so I can get everything planed correctly, because the critical dimension that you have to get with this is going to be, you want the height, of course, to be right parallel with your existing cast iron table. So you got to get this height right. The dimensions on this, the thickness for my saw is basically 1 7/8 inches. So basically, I just used the 2x4, and then I added the poplar on top, and I just planed it to make it the right thicknesses. And you really got to get that. You really want this edge on here, specifically to the transition between the poplar and the oak. You really don't want to feel anything on there. And if I wasn't looking, I can't even feel that joint on it, which is good, because you definitely don't want your wood sliding into that, hitting it and stopping when you're in the middle of a cut, right? So I guess worst case is you want the plywood to be a little bit thinner than this. If you had to, it's always best to get it right on, but you definitely don't want that edge to be sticking up. So that's just the basic top and the materials I used. Next, we'll take a look at how we actually mounted on this top onto our table saw frame. Okay, so let's talk about how I mounted this onto my actual table saw. So for the Ridgid saw, it's actually pretty easy, since they actually use this extruded aluminum track for your fence, and thankfully they actually have inside of here, which you just remove this little cover. You can slide basically a bolt down here. It's like a T-track in here, which makes mounting this kind of a snap. I know for other saws it's probably a bit more challenged. They typically don't have this. But if you have a different saw, you could just mount a piece of angle iron on here and use it for, you know, a similar attachment. So anyway, so for the Ridgid, pretty easy to do. So basically what I have is I got a couple fairly beefy hinges on the bottom of it that I got at Home Depot. They're like $5 a crack. These are basically about 3" by 3" on the underneath plate. So they're pretty beefy, and I want them to be pretty beefy. This Outfeed table does get quite heavy with all the wood that's in it and the kind of the whole mechanism. So I wanted something that was pretty hefty. I don't want this thing to be bending and deforming. So they seem to be sufficient. Haven't had any issues with it so far. Okay, so this is just some sketch I did when I started the project. Some basic dimensions that I wanted. I had just some of these numbers aren't even going to be right. They're pretty close, but I did make some tweaks to it as I went through and found some issues with it. But in general, basically, I was just looking for lengths of this, mainly of this the dovetail mechanism that I was going to build. So what you're going to find is you're going to have this, we'll call it the fixed portion of your dovetail, and then your sliding portion. So you want this to be as long as you can make it to give it the greatest stability you can. But it can't be too long, of course, because it has to actually tuck up underneath your outfeed when it's folded down. So for me, basically, my calculations, basically, I get 27 3/4 is basically the width of the depth of my outfeed table. And I was planning on setting it back about 1 3/8 inches from both sides, which comes up to meaning that this fixed portion is basically 25 inches. Whether it's, you know, plus or minus like 1/2 inch, it probably doesn't matter as long as it will still fit underneath there. And then also you have the sliding portion of it. You want the slider to be as long as you can get it, but you don't want it too short, because you might be able to extend it out, but you don't want it to be on its last 1/2 inch or inch. So you basically want it to maximize it, right? So basically this slider is about 25 inches also. So when you slide it in, you can tuck the whole piece and mechanism underneath the table, and I'll show you that how I kind of did some of that in a minute. So some critical dimensions again are the thickness of this, the 1 7/8 is critical, because that's going to set it with the being, you know, basically parallel to your cast iron table and flush with it. So down here I have some details on this dovetail assembly that I built. So my dovetail is basically made up of a piece of some plywood. It was 7 inches wide, so I used it. You can make it a little longer or wider, a little shallower. Probably the wider the better, but of course you don't want to go too wide, because it does get heavy and there's lots of material in this thing. So this is about 7 inches wide, and it's basically made up of so that 7 inch is we'll call it the fixed portion of it. And then I've got these, I had some 1 by 1 inch oak sitting around here, so I basically used those for capturing this dovetail. So it's actually kind of easy to make. I didn't, you know, so the way I was able to do it, so basically I cut my plywood with my angles on it. I didn't really care about this width. It came up to about 5 inches. It didn't have to be 5 exactly, because I cut these individually. So when I assembled it, I basically put this dovetail down, set it on top of my plywood, laid these pieces of oak in there, and then screwed those in. Again, you don't want that to be too tight. You don't want too loose. You got to play with it. You end up, I did have to sand it down a little bit to get things to slide in nicely, but it's not too bad. Okay, so let's go over the dovetail mechanism that we've been talking about. Kind of as I discussed in the drawings up there. here's kind of the main piece of it. So basically these oak, we'll call them cleats on the side. You got just a piece of plywood for the base, the 7-inch plywood. And then you got the actual dovetail slider, which is this, again, this piece of plywood 5 inches wide. Well, end up being 5 inches wide. So the way I kind of assemble this to kind of just give a quick overview. So basically, I cut the oak cleats. I think I cut them at a 30-degree angle each. Then I just cut the mating dovetail for the plywood to mate in there at 30 degrees. And then the assembly, basically you just lay this piece of plywood onto your other plywood, bring your cleats up to it, and then just screw these in. You got to be a little careful when you do that because you don't want it to be too tight. You don't want it to be too loose either. It is a little easier to take material off than to add it. So I made mine pretty tight. So I basically clamped them up together. When I put the screws in, I didn't clamp them very tight. I just really loose, just to hold it in place. Then I did have to sand it down a little bit to get it to slide in there, but it wasn't too hard. So anyway, so some of the kind of things that I did. So this, again, I stole kind of the idea off of YouTube for building this guy. A couple of things changes I made that I think are a little bit, well, improvements, or made it a little easier, at least in my eyes. So a couple things. So this little mechanism here is used to set basically it's a critical thing, is your stop distance. So that's going to set where the slider is going to stop. And then I'll talk a little bit and I'll show you. You'll see this guy down here. This is basically a gate latch that I bought for like $2. And there's a mechanism up in the top that it latches into, so it makes it easy to tuck this guy away. It's blindly. You don't have to worry about getting up under and latching it. It'll automatically latch. So that was kind of nice. I added this little handle down here, so the handle lets me move the slider a little easier when I'm monkeying with it. You don't really at least I don't plan on taking this thing up and down a lot, but it's just kind of nice to do. So I'll kind of try to show you. It's a little difficult to show with the video, but I'll show you the mechanism here a little bit. So basically, this is it's just a bolt, a quarter-inch bolt. I had a threaded knob, and I put a spring on it. So that acts as a spring, so I can pull this up and down to release it. So basically, I made these holes for the stop. And again, this is kind of a critical one because this is going to set your height. So you want him to be parallel with your table. So you have to get this guy pretty exact. And so the way I did it, before I drilled the hole, I got it all set up, and I just basically had it supported. And then I took this guy and just knocked it into it, made a little mark on it, and then drilled that hole. You'll also see there's another hole down here. So that hole is basically made so when I slide this guy up, it'll snap into that hole, keeps the thing from sliding out. So I'll just kind of demonstrate this. Again, it's a little awkward off in the video, but so basically, if I take this guy, I can pull him in and out, and I can slide him up and down. So as I close him, he'll snap basically in place, and then all I have to do now is just lift him up, and he locks underneath. So pretty easy to use. I kind of like it, and then you can just drop it down. Okay, so I guess that about does it. So just kind of wrap up. I wanted to kind of go through just a few issues and some things that you can look at if you're going to do your own. Maybe you can find a way to improve or make it a little bit better. A couple things I ran into is, number one is on the skirt of this Ridgid model, the skirt is actually a pretty piece of flimsy metal. So the problem is when that dovetail is putting a lot of pressure on that thing tends to want to bow in slightly, which will change, of course. If you got that thing sitting on there, if it pushes in, it's going to set this guy so it's no longer going to be flush or parallel with your tabletop. So something I've already got, which I haven't put on yet, I've got a piece of angle iron. I'm going to put a stiffener bracket back behind there to keep that thing from doing that. So that's a suggestion. Other tables saws may or may not have that issue. One other thing I need yet to do is to add the dado in here for my So I have my sled in here, so I've got to make sure that I got to add this dado so I can slide that in there. So today, if I do that, it's going to bang into that. So that's yet to be done. Besides that, everything worked out pretty well. You probably notice again, I'm using just a wood tabletop. I didn't use a laminate. I thought about using a laminate, and I wanted to use a laminate. The reason I didn't is because I'm kind of cheap, and I really didn't want to invest in not just the laminate, but I don't have the tools, I don't have the glue. So I'm going to end up dropping probably another $100 on materials and tools and all the good things that go along with it. And not to mention the mess and the smell. My shop's in the basement of my house. I try not to do that stuff, at least when the kids or the wife are around. But so it's something I might do in the future. Of course, it's going to impact the height, but I could take this apart actually and rework it pretty easily. Something I didn't mention, but basically I use pocket screws for almost the majority of the framing in here. I didn't glue the framing up, and I know when you use pocket screws, it's a pretty good joining mechanism. I've done a lot of different types of joints, biscuit joints, the stud and tendons. The pocket screws are really easy and they're really fast. I bought the Craig pocket hole tool about 2 years ago, and I can't tell you how many times I've used it because it's a snap to do. It doesn't require a lot of setup, and gives you a really good strong joint. As long as you get things clamped together well, when you screw them together, you're in good shape. So I really love the pocket screws, the quickness, ease, how they work. So I guess that about does it. So thanks for watching. Leave any comments. If you have questions, I'll try to answer them. But anyway, good luck if you give it a go.